presentation. Good morning, everyone. My name is Goldie Davis, and I am presenting comparison of 4 fabrics for filtering turbid water in a 2-stage crossflow filter. My supervisors are Professor Ekwe and Dr. Cooper. First of all, 2.1 billion people across the world lack an access to a safe supply of drinking water. This is according to the World Health Organization. And safe drinking water not only sustains lives, prevents diseases, but also access to it is a basic human right. Rivers and streams are surface waters which are exposed to the atmosphere and are subject to surface runoff, and these are defined as surface water. Surface water in Trinidad and Tobago provides 60% of the water supply. In rapid gravity filtration, we have the water level or pressure head, which is above the filter, forcing water through the sand media. In other words, the flow is perpendicular to the sand media. Whereas in cross-flow filtration, the flow is parallel to the filter medium, and there is little cake buildup, unlike the rapid gravity filter. My selected study site was the Acono River, right? This river supplies the Acono water treatment plant and extracts approximately 200 cubic meters of water per day from the Acono River, and it uses a rapid gravity filter to filter the water. Right, this is just one of the water treatment plants, surface water treatment plants in Trinidad, which shuts down its operations due to high turbidity levels. And this plant, when the turbidity levels reach 15 NTU, the operations are shut down, right? So this is a recurring problem with the surface water treatment plants. My objectives are to investigate physical properties such as surface roughness, thickness, weave type, warp and weft spacing, warp and weft diameters, as well as interior and pore sizes of linen, crepe-backed satin, burlap, and cotton fabrics using surface profilometry and scanning electron microscopy. I also calculated fabric porosity, and I investigated fabric tensile strength, and I used sieve analysis to investigate particle type and sizes. In surface profilometry, I measured surface roughness and maximum profile heights of the fabric, each fabric type using a Mitutoyo surf test, and a Philips scanning electron microscope 515 was used for generating images of the fabric specimen using a high energy beam of electrons. I also use a sediment transport channel to demonstrate crossflow filtration. So to do so, I had made adjustments to the channel by including a fabric filter medium, which was constructed and inserted into the sediment transport channel so that the flow of water would be parallel to it. I also did some fabric tensile testing using a Tinius Olsen universal machine. This is just showing some images of the fabric after the fabric tensile testing. Tensile testing is necessary so that I'll know if the fabric can withstand the weight of the water flowing over it without tearing, right? So that's during the filtration process, since fabric will be used as the filter medium. In scanning electron microscopy, these were the images generated for each fabric type. I was able to, the images show the differences in the weave and warp types, as well as the inter-yarn and interfiber pore sizes. The interfiber pore sizes is the space of the pores between the fibers, whereas the inter-yarn pore sizes, as shown here, is the space between each of the yarns. And using the images generated from microscopic analysis, I was able to measure the inter-yarn pore sizes using ImageJ. And this is just a table showing my results in which I listed the properties in order of importance for filtration, where inter-yarn pore size would be most important, followed by the interfiber and pore size and the porosity, fabric thickness, all the way down to the weave type, since the weave type is also important which would affect filtration, depends on how tightly woven the fabric is. I also, from the CROSSFLOW filtration demonstration, right, and the previous results obtained from the microscopic analysis and surface profilometry, I used elimination. So I eliminated cotton and satin fabric and used selected burlap and linen for CROSSFLOW filtration in the sediment transport channel. And it was found that before filtration, the turbidity was 137 NTUs, and it decreased greatly by even less than 50% for the linen. So I've even did some more further elimination from this CROSSFLOW filtration, and seeing that linen was most effective during the CROSSFLOW filtration, I also demonstrated perpendicular filtration, which is done on the plant, and it was found that linen has a 71% retention capacity. I collected samples from the Acono River. All these samples and the water samples also collected were upstream of the Acono water treatment plant, which I forgot to mention because, you know, where these samples were collected, since it is where there is the least amount of human activity taking place. And the mechanical sieve analysis found that my samples range from gravel, sand, and silt types. And I found that after all the analysis, burlap and linen consisted of the roughest surfaces. Linen has the smallest space between wefts, since when you're measuring from the measurement of pore sizes, which means that it was tightly woven. The porosity is also varied, with burlap being the most porous, 98%, followed by the cotton, and then finally the satin. Tensile strengths also varied from 462 newtons to 211 newtons. And again, burlap and linen were most outstanding in that they had the highest tensile strengths. So this was another property which I used to eliminate in my investigation. That's why I came down to selecting the burlap and linen again. And the particle types were sand, silt, and gravel, ranging from 25 millimeters to less than or equal to 0.075 millimeters, and even the pan sizes. So in conclusion, from the process of elimination, it was found that linen was the most suitable fabric and is selected for use as a filter medium. But I am going to do more testing on the fabric, and I would like to investigate turbidity over a longer period of time, instead of just 5 days from the Acono River during the actual rainy season. I also started the construction of a pilot scale 2-stage CROSSFLOW filter. And when this is completed, I will execute filtration tests to determine the flow and turbidity using the linen fabric filter medium. These are the references that I used. Thank you, everyone. And that is the end of my presentation.
Thank you so much, Ms. Davis. We are open for questions now.
Okay, so we have a question from Dr. Beichu. Will these fabric filters be more efficient in dealing with the high turbidity encountered during flooding in the wet season?
Well, it should be. So far from my tests, it has proven that it is quite effective with the turbidity, the linen fabric in particular, and that is the aim of my research. So if it is more efficient, it will prevent the water treatment plants from shutting down by retaining more particles.
Okay, so I thought that your presentation had a lot of, the research itself has a lot of regional significance, especially now when we're in a time where we can see how we're worried about water availability. And I noted that you said one of the things that you wanted to do was to design, well, you can have a model, right?
Yes, yes.
So in your original experimentation, I think I might have missed, it might have gone over my head at the time. What volume or flow rate of fluid were you trying to work with in terms of the filtration?
My targeted flow rate is 23 liters per second. Yeah, well, that is the targeted, that is the flow rate at the present flow rate at the Acono plant.
Okay.
So right. I'm aiming at that.
Right. So the aim is to have something that is in line with what you currently have.
Yes, that is correct.
The plant.
Yeah.
Okay. All right. There's another question here, which from Mr. Mohammed, which says, do you think it could be possible to use either recycled fabrics or fabrics made from recycled material for the purpose of filtration?
Yes, I think that is a possibility, but what I looked at, what I considered when I was doing the research was to find fabric that was easily and readily available and also affordable. So, you know, if you just go into the fabric, so that's how I look at it. I didn't really go into the recycle fabrics, but I can keep that in mind. Thank you.
Mm-hmm. And then you looked at cross flow and perpendicular flow.
Yes.
What would you be more likely to use in your filtration, in a filtration plant, and why?
Okay.
How would it affect the design of your?
Okay, in the surface water treatment plants in Trinidad, we have rapid gravity filters, which uses sand and gravel filter medium, right? So those flow is perpendicular. And the problem they are experiencing at present is that the filter medium clogs. It becomes easily clogged. Mm-hmm. So that is part of a lot to do with why the treatment has to, the operations has to shut down during high turbidity levels, because they are unable to have a constant filtration process. So in using the CROSSFLOW filter now, it will have little cake buildup, because being as the flow is parallel to the filter medium now, it will take away the particles from the filter medium and avoid cake buildup. It wouldn't be as quick as in the perpendicular filtration.
Understood. And are there any cost considerations that you have to worry about with this introduction of this fabric filtration?
Well, I'm trying to be very economical with my filter design, and right now I am in the process of obtaining the cost of installation of a rapid gravity filter there at the plant.
Okay. Are there any other questions? Right. In the tensile tests conducted, was there a significant variation from one sample to the other for the same material? If so, how are you going to account for that in the design?
Well, from so far, right, this tensile testing was done using it wasn't the appropriate tensile machine for fabric type. So when I conducted the fabric tensile testing, there wasn't any variation. It just showed like the fabric, whether it feel immediately, like for example, the cotton and the satin feel, but the linen was constant and the burlap in the readings, it didn't really vary, if that's what you meant. And further testing using the actual fabric tensile machine, I will be able to determine that if there are any variations.
Okay. So I think the question was really, whenever you have non-homogeneous objects, you tend to have a spread in the results you get for anything. And we were wondering if the tensile test had a significant spread that way. Because it's not homogeneous. It depends, even because it's a woven fabric.
Yes, for each, if you're comparing each fabric type, yes, there were differences. So the linen and the burlap tensile strengths were much higher than the cotton and the satin.
But within each material, the values were not too far from each other.
No, no, no.
Okay, thank you so much, Ms. Davis.